All right, Matt, hey, here we go. We've got some multiplication with exponents. All right, so we expanded the other day. And what we're going to do today is show how we can use expansion to find out rules for exponents with our different operations that we're going to have. First of all, what does an exponent do in the first place? Well, we found out yesterday, or whatever day it is for you, we found out the other day that an exponent keeps track of how many times a number is being multiplied by itself. So it tracks how many times a number is multiplied by itself. Okay, so now we have some multiplication problems, and we're going to simplify these by using expansion. Sorry about the print. I don't know what happened. Printer was not being nice. Anyways, here I've got x squared times x squared. But by expansion, I know that I've got x times x, that's the first x squared, times x times x. So I can simplify and say, oh, I've got 1, 2, 3, 4 x's. It's 4 of the same things. So we would do x to the 4th power, because all those x's are the same. On this next one, if I did expansion, on the first part, I would have an x and 2 y's. On the second one, I would have 3 x's and 3 y's. So if I'm simplifying this, it looks like I have a total of 1, 2, 3, 4 x's, x to the 4th. And I've got 1, 2, 3, 4, 5 y's, y to the 5th. Next one. Looks like in the first section, I've got 4 a's and 1 b. In the second section, I have 1 a and 1 b. So I've got 1, 2, 3, 4, 5 a's, a to the 5th. And I've got 1, 2 b's, b to the 2nd. Everything's being multiplied, so we can just simplify with exponents for this one. All right, does there appear to be a rule we can use for multiplying with exponents? Well, let's look here. I had x to the 2nd, x to the 2nd, and I got x to the 4th. Interesting. Here I had x to the 1st and x to the 3rd. I got x to the 4th. And then y to the 2nd, y to the 3rd, got y to the 5th. Over here, I had 4 a's and 1 a. There's 5 a's. And then 1b and 1b, and it became b to the 2nd. So hopefully you can see there that there does appear to be a pattern or a rule that we can use. It appears as if the exponents are being added together. So the exponents of like bases are added under multiplication. Now I said like bases because over here, the x's and the y's were not intermixed. The x's had their own thing going, 1 plus 3 more, and the y's had their own thing going, 2 plus 3 more. So it's only like bases where we can add them together. So if I were to do this original problem with an exponent rule, this is what I would do. This would be x to the 2 plus 2 power, because the rule is we can add the exponents of the like bases. So that would become x to the 4th. This one would be x to the 1 plus 3, and then y to the 2 plus 3. Which comes out to x to the 4th, y to the 5th. Next one, I've got a to the 4 plus 1, because I'm only doing a's, the like bases, 4 plus 1, and then b to the 1 plus 1. So that becomes a to the 5th, b to the 2nd, exactly what we got right there. All right, things get a little muddled when we start doing it with coefficients. So if I have a coefficient and exponents, exponents and coefficients behave differently with multiplication. Okay, so they don't follow the same rules. While exponents are, we said they were added, coefficients should be multiplied. So looking at this, the coefficients are 3 and 4. Since this is a multiplication problem, they are just multiplied. Coefficients behave normally. 3 times 4 is 12. And this is y to the first, so then I would do y to the 1 plus 3. So the coefficients were multiplied, but the exponents were added together. We get 12y to the fourth. Next one, negative 2 times 6. Those are my coefficients. I get negative 12. And then we get a to the 6 plus 3. Final answer, negative 12, a to the 9th. Next one, negative 7 and negative 5 are my coefficients. I multiply them and get positive 35. Then I've got x to the 3 plus 10. But there's only one y. So it's like 0 plus 1 or just 1 up there. Final answer is going to be 35, x to the 13th, y to the first. Last one in this example, 11 times 8, that's my coefficient, I get 88. D's, d to the 3, and then I have 5 d's over there, so 3 plus 5. This is all multiplication, so I'm just keeping track of how many d's I'm multiplying. Looks like I have 8 of them. Over here, f, different base, so f's only go with other f's, to the 12 plus 9. Final answer, 88, d to the 8th, and f to the 21st. You can expand with all these to see these same answers. The only problem with expansion when it looks like this is you don't want to have to write down 21f's. So learning the function rule or the exponent rule is really helpful. Here's 12 problems. If you're doing this on your own, I would pause at this point and try it out, and then unpause and check to see how you did. All right, so pause it right now. And in a second, unpause it, and you'll see how I did. All right, so on this one, my base is 9, and I add the exponents. 9 to the 4 plus 7. That would be 9 to the 11th power. This one, my base is 6. This is 6 to the first, so this would be 6 to the 1 plus 5. 6 to the 6th. Next one, my base is y. This would be y to the 2 plus 12. Y to the 14th. Next one, my base is 8. This is x to the first. So this would be x to the 1 plus 7, x to the 8th. Next one, my base is m. So this would be 11 plus 13, which would be m to the 24th. Next one, I have two separate bases. I've got a base of a and a base of b. We cannot interchange them. So this would be a to the 1 plus 3 and b to the 6 plus 1. That gives me a to the 4th, b to the 7th. Next one, d to the 4th and d to the 1st. So that'd be d to the 4 plus 1. And then e to the 4 plus 9. That gives me d to the 5th, e to the 13th. Next one has coefficients. Coefficients behave normally, so I just do 2 times 5, 10. And then the exponents, we add, the bases, we add gosh, can't talk. Like bases, we add the exponents. So 1 plus 3. So this would be 10 x to the 4th. This one's a little bit tricky. We've got a negative out there. That means negative 1. So my coefficient's negative 1 and 3. So I multiply that and get negative 3. And then b to the 2 plus 5. Negative 3, b to the 7. 3 more. Coefficients are 2 and 9. That makes 18. Base, h. Exponent, 10 plus 20. we get 18h to the 30th. Next one, coefficient, -6 and 3. We get -18. Base, x and x, so 1 and 7. So it'd be x to the 1 plus 7. Y and y, there's the same base, so I get y to the 3 plus 9. -18, x to the 8th, y to the 12th. Next one, -7 times -2, 14. Base, a to the 7th, but there are no a's over here. So I'm just going to leave it as a to the 7th. You could do a to the 7th plus 0 because there's no a's over there. That would be workable. And then b to the 3 plus 15. Final answer, positive 14, a to the 7th, b to the 18th. All right, now I know what you're thinking. Why isn't he just getting to the answer? Why is he doing all this extra work? Okay, there's a reason for doing these steps in it. Number one, it's just good practice to show your work. Number two, we're going to be doing a whole bunch of different operations with exponents and getting it nailed down in your head that you are adding for these multiplication problems is super important right now. Don't be lazy. Get in the habit of writing what's happening to your exponents. The more times you write it, the more it gets stuck in your head and you remember the rule. So make sure that you're doing this intermediate step right here and showing that you're adding the exponents. It'll help you out later on, trust me. All right, that's all I got. Math hard. See you guys later. Bye-bye.